Assalamualaikum everyone. My group mates and I are going to present on the nuclear physics. The various types of radiation around us are indicated in the electromagnetic spectrum as below, ranging from the radio wave that has the low energy to gamma radiation, which has the high energy. There are two types of radiation. First is the non-ionizing radiation. Radio wave and microwave are classified into the non-ionizing radiation. It has the low frequency, low energy, but with longer wavelength. The other one is the ionizing radiation. X-ray and gamma rays are classified into the ionizing radiation. It has the high frequency, high energy, but with shorter wavelength. In this chapter, we are going to present on three subtopics. First is the properties of ionizing radiation. Next is the radiation detection, and the last one is the radiation safety.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shami and I'm going to explain about properties of ionizing radiation. For the first part, ionization occurs when an electron in the inner orbit of an atom receives sufficient energy to escape from the influence of the nucleus. This will cause the formation of the positive ion and a negative ion. Therefore, the characteristic of radiation, which is X radiation, is emitted when electron from outer shells falls in to take the places left by an electron that was injected at first place. Ionizing radiation will cause ionization when they pass through matter, and alpha and beta particles and gamma rays emitted spontaneously from other nuclei of unstable atoms during radioactive disintegration. In the radioactive materials, the radiation is emitted continuously in a regulated manner, and there is no way of stopping it. The last part, X-rays are produced by the sudden deceleration of an electron in the strong field of the target nucleus. And X-ray machines emit radiation only when the machine is energized. So when the voltage was disconnected to the machine, meaning that there's no X-ray emitted. Thank you.
I will continue with the next subtopic, which is the properties of alpha, beta, and gamma radiation. Let us continue to the next part, which is the first one, properties of alpha particles. Okay, alpha particles are made up of 2 protons and 2 neutrons, which exactly the same as the nucleus of the helium. Alpha particles doesn't have any electrons, so its overall charge is positive 2, which comes from the proton. Neutron doesn't have any charge, so that is why alpha particles are said to be positively charged particles. Okay, and alpha particle is strongly ionizing, which means they can easily knock off any atoms that they collide with. Okay, because the ionizing power is strong, the penetrating power will be low because they cannot penetrate very far into other materials, and it only can travel like a few centimeters in air and can also be stopped by paper, skin, or thin cut. Okay, so here the mass of alpha particle is 4 AMU. Next is the properties of beta particles. Okay. Beta particles are actually electrons, so they have a charge of -1. How they get the charge of -1? Okay, you can see the picture at the top of the title there, beside the title. Okay, we have nucleus there, and the nucleus contain neutron and proton. The neutron will split up into a proton and an electron. So the electron will be emitted out, but the proton will stay inside the nucleus. The electron that had been emitted out is what we call beta particle. Only one electron had been emitted out at high speed. And it also released a gamma ray. Okay. Beta particle is a bit tiny, so the ionizing power will be moderate, which means beta particles can penetrate moderately far into materials. For example, it will take several meters of air or a thin metal force to stop there. Beta particles penetrating power is greater than alpha particles. This is because they can penetrate to thin metal foil, but alpha particle only can penetrate through skin layer, sheet of paper, thin cut, and it will stop there. Not like beta particle. They will stop when they penetrate through metal foils. And the mass of beta particles is 1/1850 AMU. The next one is gamma rays. Okay. Gamma rays are not particles at all. They are actually wave of electromagnetic radiation. As you can see at the what is it box right there. Okay, inside there, it shows that gamma rays is an electromagnetic wave consisting of photons. And gamma ray also will be emitted after alpha or beta radiation. We can go to the previous slide here. You see the beta decay picture. The gamma ray is released when beta radiation occur. Okay. Gamma ray doesn't have any mass and charge. Okay, the charge are neutral or is equal to 0. So when they don't have any charge or mass, they tend to pass straight to the materials. Okay, they tend to pass straight through the material rather than colliding with any of the atoms. Okay, so they have very weak ionizing power, which means they can penetrate really far into materials before being stopped. Okay, and when the ionizing power is weak, obviously the penetration power will be very high. That it is very high that they can penetrate through thick metal blocks or lead. Okay. So this is the example of penetration power of each radiation. As you can see here, alpha particles only can penetrate through paper, and then it will stop there. Beta particles can penetrate until aluminium plate, and it will stop there. But gamma ray, it can penetrate through lead or metal block, and then it will stop there.
Hello, Assalamualaikum. Today I am going to talk about radiation detection. What is radiation detection? Radiation detection is in experimental and applied particle physics, nuclear physics, and nuclear engineering. A particle detector, also known as a radiation detector, is a device used to detect, track, or identify ionizing particles such as those produced by nuclear decay, cosmic. Okay, when talking about radiation detection instrument, there are 4 types of detectors that are most commonly used depending on the specific needs of the device, which is portable radiation monitor, area radiation monitor, personal dosimeter, and also monitor for internal radiation contamination. So I will talk about the portable radiation monitor first. So what is portable radiation monitor? Actually, you know the Geiger counter and scintillation counter. They are a type of portable radiation monitor. Geiger counter is a device for measuring the radioactive by detecting and counting ionizing particles, and also scintillation counter is a device for detecting and recording scintillations. Especially in order to measure ionizing radiation. So next I will talk about Geiger counter and scintillation counter. These are battery operated handheld meter, and they are also used at radiation facilities and work sites to ensure that the radiation level is within the limits. Specific in the radiation protection, which is ionizing radiation. The radioactive source must be returned to its safe position or to check that contamination of surface has not occurred. That's the function of portable radiation monitor. Next, we will talk about how GM works. So, firstly, as you guys know, the GM works when radiation enters tube through the thin mica window, and the radiation collide with a gas molecule that contained in the tube. It causes the ionization. Some of the gas molecule and in the tube will turn into positive and also negative ion. Negative ion we call it as electrons. Next, positive ion will attract to the metal tube because metal tube is a cathode, while electron, which is negative ions, will attract to the central wire because central wire is anode. Okay, next, many electrons travel down the wire, making a burst of current in a circuit connected to it. The electron will make the meter needle deflect. Before the counter can detect any more radiation, it needs to be restored to its original state. Electron, it will flow to the metal tube and neutralize it. That's how the GM tube works. So next, we will talk about area radiation monitor. Okay, area radiation monitor is the most portable survey. Meters are intended for dose rate measurement, while some have integrated facility which enable the total dose in a given time to be recorded. I'm sorry. Okay, next, the prime purpose of the type of monitoring instrument to give an indication of external radiation level present in an area where ionizing radiation occur. In some cases, it sounds an alarm if the level exceeds a predetermined value, means is more higher than the value is supposed to be. Next, every radiation monitoring system usually are designed to respond for gamma radiation and may use either GMT or ionization chamber in detecting the hits. Okay, this is the example of the radiation monitor. Next, for the rest, my friends will discuss it for you. Thank you.
Hi, next I will continue for the personal dosimeter. Personal dosimeter is used to determine how much radiation is received by a radiation worker in the course of his work. There are three types of personal dosimeter. The first one is thermoluminescent dosimeter, that is called a TLD batch. The second one is quartz fiber electroscope, that is called a QFE dosimeter. And the last one is beeper. This is the example of beeper, and this is the example of QFE, and this is the example of TLD batch. TLD batch consists of 2 lithium fluoride chips mounted on a card and encased in a special holder. It is worn like a badge on the body for 1 month or 2 months depending on the nature of work. During this time, the amount of radiation which the worker receives is recorded on the TLD chips. After 1 or 2 months, the used card is exchanged for a fresh card. Lithium fluoride being used in TLD batch to store energy during exposure of ionizing radiation and subsequently release it as light when heated. This is an example of lithium fluoride. How does TLD works? Okay, TLD works by storing the energy they receive from ionizing radiation. Then, until they are heated to high temperatures such as 250 degrees Celsius, then on heating, the absorbed energy is released in the form of visible light. The last one is a plot of light intensity emitted against temperature is known as a glow curve. The second one is QFE dosimeter. This is the example of QFE dosimeter. It is used for workers involved in non-destructive testing or NDT work. The QFE dosimeter contains a quartz electroscope in a small ionization chamber and is provided with an optical system. The advantage of this dosimeter is that it gives an immediate reading of the dose received by the wearer. It is very useful for individuals who need to enter a ration error to do a particular job. Reading dosimeter is just point it at light source so that we can look through it and see the scale. Aero test dosimeter use an extremely sensitive fiber electrometer type voltmeter and a small volume of air to measure the total amount of radiation to which the instrument has been exposed. The last one is beeper. This is an example of beeper. Miniature GM tube in a small instrument which are carried in the pocket. They produce an audible beep warning sound at a rate dependent on the radiation level. When a predetermined dose rate is exceeded, it will give a warning note which increases in frequency with dose rate. Okay, this is the instrument that used for measuring external exposure. The first one is GM counter survey meter. The purpose is to contamination detection as it has a thin entrance window and can detect beta particles efficiently. The second one is ionization chamber or ionization chamber survey meter. The purpose is to find the alpha ray ambient dose rate, as it is most accurate but unable to measure low dose rate like a scintillation type can. The third one is null T scintillation survey meter. Is used to alpha ray ambient dose rate also, as it is accurate and very sensitive. The last one is personal dosimeter that used for personal dose cumulative dose. There is one on the trunk of the body to measure personal dose equivalent of the relevant percent exposure while it is worn. Okay, this is the differentiation between the external versus internal radiation exposure. For the external exposure, it comes from the outer space and the sun or body surface contamination, suspended matter, from a radiation generator or from building and from the ground. Radiation coming from outside of the body. For the internal exposure, it comes from inhalation, food and drink consumption that come to the lungs and from the lungs and from the radiopharmaceuticals, radiation emitted within the body. Moreover, measurement for internal contamination can be done on body excretion. Then, urine and feces are collected to measure excreted radioactivity. The last one is excretion rates are calculated to determine the total intake. There are comparison or method of assessing internal radioactivity. The first one is by direct counting. Direct counting is directly measure the human body that need to spare time to receive direct measurement. It's mainly target material that emits gamma ray. The short measuring time using the apparatus, accurate dose assessment. This is the example of direct counting. The second one is bioassay. It is indirect measurement by submit samples such as urine, feces, and another else. It's able to measure all radioactive material. The chemical analysis take times. The large measure of error in result of those assessment. This example of the bioassay by using urine. The last one is instrument for measuring internal exposure. The first one is stand-up whole body counter, scanning back whole body counter, chair whole body counter, thyroid, and the last one is thyroid monitor. Okay, that's all from me. Thank you.
Radiation safety. There are two sources of radiation. First one is the natural sources, which is the cosmic radiation, terrestrial radiation, and internal radiation. The second one is the man-made sources. Man-made sources is any radiation sources produced by humans such as X-ray. There are three principles of radiation safety. First is the time. Radiation exposure can be accumulated over the time of exposure. The longer the exposure time, the more radiation exposure to the pain physician. The second one is the distance. A greater distance from the radiation source can reduce radiation exposure. The amount of radiation exposure is inversely proportional to the square of the distance. The last one is the shielding. There are many shielding devices such as caps, lead glasses, thyroid protectors, apron, radiation reducing gloves, and others. Dose limit for radiation workers. The dose limit is designed to prevent the incidence of deterministic effects by keeping the dose limit below the threshold values for deterministic effects. The dose limit recommended by ICRP in 1990 to be 20 millisievert a year, averaged over defined periods of 5 years, and with the further provision that the effective dose shall not exceed 50 millisievert in any single year. The aim is not to just keep within the dose limit, but to ensure that protection is optimized and the exposures are all kept as low as reasonably achievable economic and social factors being taken into account. Dose limit for public. For members of the public, the dose limit is 1 millisievert per year. A higher value of effective dose could be allowed in a year provided that the average over 5 years does not exceed 1 millisievert per year. The occupational dose limit for women who are not pregnant shall be the same as that of men. Once pregnancy has been declared, the equivalent dose limit to the surface of the woman's abdomen shall be 2 millisievert for the remainder of the pregnancy. Radiation accident is an unexpected, uncontrolled high level of ionizing radiation occurs as in the case of loss by damage of the radiation shielding of a sealed radioactive source of irradiating apparatus. It also can occur when an individual enters a high radiation field by accident. Then there is a loss of control of unsealed radioactive material causing a spillage or leakage of the radioactive material. It also can be by the skin or clothing of an individual becomes contaminated. And the last one is radioactive material is accidentally released in the environment in excess of the discharge level permitted by the regulations.
Next is emergency procedure. Okay, first, what is emergency procedure? Emergency procedure is a plan of action to be carried out in certain order or manner in response to a particular class or reasonably foreseeable. A situation which poses an immediate risk to health, life, property, or the environment. A radiation accident or incident can also be part of another hazard, such as a medical emergency, fire, or chemical hazard. So for the first step for emergency procedure is evacuate all individuals from the affected area. And number 2 is block off the affected and post warning sign at all and its entrance. And next, take immediate action. This is to reduce the hazard caused by the radiation accidents. And number 4, please make arrangements to provide temporary shielding, monitor and decontaminate any affected individuals. And number 5, ensure that any contamination in excess of permitted limit for skin of any individual is removed before the individuals leave the premise. And number 6 is ensure that any personal clothing or private property which is contaminated by radioactive material is not taken from the premise. And number 7 is refer affected individuals for a medical observation and treatment. Next is the effect of the radiation. For information is divided for a 2 type, which is effect when you exposed to a very high radiations, such as being close to an atomic blast, can cause acute health effect such as skin burn and also acute radiation syndrome. Another name for acute radiation syndrome, which is a radiation sickness, such as you will have a symptom like nausea and vomiting. It may also contribute to a long-term health consequence such as cardiovascular disease and also cancer. When you're exposed to a low radiation, it may not causes immediate health effect, but it's a small contributor to our overall risk of cancer, such as leukemia. And for information, children and fetus are especially sensitive to radiation exposure.